Hello stats class, this is Mr. Harding. This video is for the notes for 5.5. You notice that 5.5 is all about the central limit theorem. The central limit theorem, this is probably the most important thing I'm going to say during the course of this video. The central limit theorem only applies to sample means. There are two different types of sampling distributions that we have talked about in chapter 5. We talked about sample proportions in 5.3. I'm bringing it up right now, right? We talked about sample proportions. In 5.4, we talked about sample means. In 5.5, the central limit theorem is for sample means only. Okay? So, some other information before we start to talk a little bit more about the central limit theorem. Obviously, we don't always sample normally distributed populations. I'm sure that's something that some of you have considered as you've looked over some of the exercises you've done in our class. It seems like, well, the population's always normal, which seems a little far-fetched, and I agree with that. It's not the case. But what you should notice in the 5.5 activity, with whether you've done it or not yet, you'll end up seeing this. But as your sample size increases, the population distribution does not necessarily need to be normal. And this is known as the central limit theorem. Well, you notice down here it says when n, which obviously is your sample size, is large, the sampling distribution of the sample means, remember this is means only, becomes approximately normal. So the only other thing that you're probably thinking about right now, well, large is quite relative, and I agree with you 100%. Large is a relative term, and that's on purpose, that's by design. It's difficult to consider every single population distribution under one instance. Okay, it's just not realistic. And so that's why the word large is used, because depending on the shape, and I imagine most of you are thinking about this, and if not, when I say it, hopefully it makes sense, but the larger the skewness. Like if you have a strongly skewed distribution, then that sample size is going to have to be pretty substantial. If you have a slightly skewed distribution, then the sample size doesn't need to be as large. That's the idea behind the relativity of this term large. Okay, so what this allows us to do, and what we're referring to in large, is we now have two checks for normality. If you were someone who took the quiz on Friday, or if you've just honestly been paying attention in class, we have been talking about making sure that we do some checks before we find the probabilities of some things. And one of those checks has been the same for both proportions and means. We have checked the independence of a sample. And what we had said is the sample size can't be larger than 10% of the population. Then there was another check, and that other check was for normality. You got to make sure that we have an approximately normal sampling distribution, or else then we can't use the normal curve to find probabilities, which is what we did in chapter 4. So we had talked about, again, this is for sample means only. The check that you knew was that the population distribution had to be approximately normal, right? I'll go back to it right now. See this at the bottom here? If the population distribution has a normal shape, so does the sampling distribution. Okay? The sample size doesn't matter for that. If you have a population that is approximately normal, you're good to go. But you might not have a population that's normal. And so that's where this new thing comes into play called the central limit theorem, which says the sampling distribution will be approximately normal in most cases if the sample size is bigger than 30. So that is what we are going to use in our class, is we need a sample size of 30 or bigger. And then if we are dealing with a population that's not normal, we will still be good to go. That is section 5.5. Okay, that is it. It's a very easy section, which is why I think you guys can do the work outside of class, even if you weren't here on Monday to hear this from me. So please make sure that you are following along with Schoology and doing everything else that you are supposed to do. If you have questions, please let me know and just reach out via email.